Hey everyone, Rob here from MTU's Blackrock Castle Observatory. Hope you're enjoying the Cork Harbour Festival so far, and we're sorry again that you were not able to join us today on account of the poor weather to see the moon in person. So what we're going to do instead is use this cool piece of astronomy software called Celestia to show you what you would be seeing if you were able to join us today. So we're in a situation where you can see half the moon here. A lot of people don't quite understand the phases of the moon and why you see certain parts lit up at certain times. It's basically down to the position of the sun. So from our perspective right now, the sun is over here to the right. So if I were to rotate the moon, I'm sure we would see the sun. There you go. And as the month progresses, the position of the moon relative to the sun will change, and I'll show you that here by accelerating time. So the sun is moving in behind us here now, and when it's right behind us, you get the full moon. So that's all that happens. And by the time you have what we call the new moon, all that will have happened is that the sun will be completely on the other side. So the moon looks blacked out from our perspective. Now the moon is what we call, there you go, there's the sun. The moon is what we call tidally locked. It means that we only ever see one face, so it doesn't spin on its own axis as it spins around us. Now, we have some features on the surface of the moon, and they're quite interesting. There's a pretty sizable difference between both sides of the moon. You may have heard the other side of the moon referred to as the dark side of the moon, which isn't accurate. In fact, it's actually quite light relative to this side of the moon. If you were to flip it around right now, you'd see there's very few of these seas, as we call them. Now, that's primarily down to the fact that the seas are caused by volcanic activity. Those are basically lava flows that have cooled off in the low-lying areas of the near side of the moon. We're not 100% sure why there are more of these seas on the near side of the moon than there are on the other side. One of the reasons may be down to the difference of thickness in the crust. I've heard theories that the impacts on the other side of the moon led to the volcanic activity on this side of the moon, and then you end up with just this cooling basalt that leads to these areas that look like seas. There's a whole bunch of different factors that might be at play, but obviously we don't know exactly what happened back when the early moon was formed. We still have a lot of theories that we're testing and exploring. Now, while they're not seas, they are named after seas, so some of them have quite interesting names. The Sea of Tranquility is probably the most famous one. That's down around here. So if you've heard of the man on the moon, the man on the moon is this guy here, is his head. There's the body. You've got your left leg and your right leg. And where his appendix would be in here, that's the Sea of Tranquility. There are some other seas on the surface of the moon as well. We're just going to change the direction of the sun here so that this stays lit up for us. There we go. So this one over here is called the Sea of Crises, which I think is kind of funny. But my favorite is probably Mare Cognitum, which means the sea that has become known. And that's over around here. That's just a very funny name for a sea from my perspective. Now, we also mentioned that we were going to talk about how to navigate using the stars. So to do that, I'm going to need to open up another app. So just bear with me for one moment. Okay, so here we are. This is the sky outside minus the clouds as I'm recording this. So it's just after 4 o'clock. The moon is over here in the southeast. But to see the stars, we're going to need to jump ahead in time. But briefly, I'll let you look at the moon again as it looks right now, just to show you that what we were looking at was accurate. I should mention again, the Sea of Tranquility, as I called it, is actually the whole area, not just the appendix. The appendix is where Apollo 11 landed, so that's where Neil Armstrong and Buzz Aldrin took those famous first steps on the moon. So we'll zoom back out again, take our focus off the moon, and we'll jump forward in time to nighttime. So this is about midnight tonight. You can see the Milky Way is showing up here. Slow time back down again. I'll bring up some of the constellation lines, as well as the constellation art. So to get an understanding of how we might use these constellations, these shapes in the sky to navigate on the sea, well, the easiest example would be to look at Ursa Major, so the Big Bear as it's called. Now the part of Ursa Major we're most familiar with is probably this asterism here, the Plough, or the Big Dipper as it's often called. We rarely see the the full or some major here in the city, just down to light pollution. These lower magnitude stars tend to get washed out, but the Big Dipper itself is generally visible throughout the city. Now, if you were to treat it as the saucepan that I think it looks like, you've got a handle here and then the body of the saucepan, that's how you use it to find the North Star. So come in along the handle here into the body of the saucepan, follow it back out along the rim, and then as you head out here, you come to this bright, beautiful star called Polaris, and Polaris is the North Star. So we'll center that to give you an idea of why it's the North Star. So it's the North Star because it's directly above us at all times, above the Earth, that is, above its axis. So as all the other constellations spin around us, it stays exactly where it is. So it's an extremely useful reference point for north. Now, one cool thing we can discover from our sky culture about how we were able to use constellations to navigate and the significance of constellations as navigational objects is in comparing the difference between the constellations as named in the Northern Hemisphere by the Greeks and the Romans versus those seen in the Southern Hemisphere once we started exploring. So the earliest constellations that we know of were named after animals and people and things that we were quite familiar with. But when we developed the tools needed to start navigating into the Southern Hemisphere and exploring that, well, I'm just going to get rid of the ground here to let you see what the Southern Hemisphere constellations look like. There's fewer animals and far more tools. So things like sextants and ships and tools like telescopes that we would have used to explore and compasses. So it gives you an idea of just how important the constellations were in navigating into these new lands, or at least new lands from the perspective of those of us living in the Northern Hemisphere. So I hope that gives you a taste of how the constellations were used for stellar navigation. Apologies again that you weren't able to join us today, but hopefully we'll have better weather by the time the next first quarter moon rolls around, and we'll see you again at the observatory to view some of these things in person. Thank you for your time, and I hope you enjoy the rest of the Cork Harbour Festival.